On the morning of March 12, 1943, at precisely 10:45 hours, Captain Harold Garrison stood on the deck of the SS Liberty Star, a Liberty ship anchored at the Brooklyn Navy Yard, examining what would become one of the most unusual merchant vessel modifications of World War II. Before him lay the complete nose section of a Boeing B-17F Flying Fortress bomber that had crashed during a training flight in Pennsylvania 2 weeks earlier. The aircraft was destroyed, the crew had perished, but the forward fuselage section from the bombardier's position to just aft of the cockpit remained structurally intact. The SS Liberty Star was a standard EC-2 S-C-1 Liberty ship, one of 2,710 identical vessels mass-produced for wartime cargo service. Built at the Bethlehem Fairfield Shipyard in Baltimore and launched on January 8, 1943, the vessel measured 441 feet 6 inches in length with a beam of 56 feet 10 inches. Powered by a single 2,500 horsepower triple expansion steam engine, the Liberty Star could achieve 11 knots maximum speed, slow and vulnerable, but capable of carrying 10,800 deadweight tons of cargo. By March 1943, the Battle of the Atlantic had reached a critical phase. German U-boats were sinking Allied merchant ships faster than they could be replaced. During the first 3 months of 1943 alone, U-boats sank 203 Allied vessels, totaling over 1.1 million tons. The Liberty ships, despite their impressive production rate, were particularly vulnerable. Their slow speed made them easy targets. Their minimal defensive armament, typically one 3-inch gun aft, one 5-inch gun forward, and 8 20mm Ehrlichen anti-aircraft guns, was inadequate against determined attack. The greatest vulnerability occurred when U-boats attacked on the surface at night. German submarine tactics in 1943 increasingly favored surface attacks under cover of darkness. U-boats could travel faster on the surface, their low profile made them difficult to detect visually, and their deck guns could engage merchant vessels from ranges where return fire was ineffective. Liberty ships needed better forward-firing armament to defend against surfaced submarines approaching from ahead. The B-17F Flying Fortress bomber represented the most heavily armed bomber in American service in early 1943. The forward section alone contained extraordinary firepower. One .50 caliber machine gun in the bombardier's nose position, 2 .50 caliber guns in the upper turret, and 2 .50 caliber guns in the lower ball turret, though the ball turret would be irrelevant for ship installation. More significantly, the B-17's nose section provided excellent visibility through the plexiglass bombardier's station and navigator's windows. The crashed B-17F's nose section was approximately 18 feet long, measured from the forward bombardier's position to the firewall separating the cockpit from the bomb bay. The structure included the complete bombardier's station with the Norden bombsight mount, the navigator's station with chart table and astrodome, and the bombardier's .50 caliber machine gun on a flexible mount. The entire structure weighed approximately 1,400 pounds, including equipment, framing, and plexiglass panels. Captain Garrison examined the B-17 nose section throughout the morning of March 12th. The bombardier's position offered superior visibility to any merchant ship bridge. The plexiglass nose cone provided nearly 180 degrees of forward vision. The single .50 caliber gun was already installed and functional. The navigator's astrodome could serve as an observation post. The entire structure was aerodynamically designed, presenting minimal wind resistance compared to a conventional ship superstructure. At 1300 hours, Captain Garrison convened a meeting with Commander Robert Mitchell, the Navy's liaison officer at Brooklyn Navy Yard, and Chief Boatswain John Crawford, the yard's senior structural supervisor. The proposal was unprecedented. Mount the B-17 nose section on the Liberty Star's forward deck, positioned above the existing 5-inch gun platform to serve as an elevated observation post and forward gun position. The engineering challenges were substantial and multifaceted. The B-17 nose section was designed to attach to an aircraft fuselage with specific mounting bulkheads and structural interfaces. A Liberty ship's deck structure consisted of steel plates over frames and beams designed to support cargo loads and deck equipment. The two structures came from completely different engineering disciplines with incompatible attachment methods, materials, and structural requirements. Commander Mitchell began feasibility analysis immediately. The B-17 nose section would need to be mounted approximately 15 feet above the main deck to provide clear sight lines over the forward cargo hatches and the existing 5-inch gun mount. This elevation would create significant wind loading on the structure. The nose section would act as a sail, catching wind and creating forces that must be transferred to the ship's structure. The weight of 1,400 pounds was manageable for a Liberty ship, negligible compared to cargo loads of thousands of tons. However, the weight would be positioned high above the deck, raising the vessel's center of gravity. This could affect stability, particularly in heavy seas. The modification would need to be analyzed for its impact on the ship's metacentric height and stability characteristics. Chief Crawford proposed fabricating a steel pedestal structure that would elevate the B-17 nose section above the forward deck and transfer loads to the ship's main structural frames. The pedestal would be constructed from heavy-duty steel pipe and channel sections, welded to form a rigid framework. The structure would be bolted to reinforced deck plates positioned directly over main transverse frames for maximum strength. The crew accommodation would require modification. The B-17 nose section contained two positions for crew members, the bombardier in the forward position and the navigator in the aft position. For merchant ship use, these positions would be reconfigured. The forward bombardier's position would become a lookout station with the .50 caliber gun for defense. The navigator's position would become a forward observation post for the officer of the deck or lookouts. Access to the elevated nose section required a ladder system. Crawford designed a steel ladder running from the main deck up to an access hatch cut into the bottom of the B-17 fuselage. The ladder would be 15 feet tall, incorporating platforms at 7.5-foot intervals for safety. The access hatch would be positioned in the B-17's belly, approximately where the lower ball turret would have been in the complete aircraft. The ammunition supply presented challenges. The .50 caliber machine gun in the bombardier's position would need substantial ammunition storage. B-17's typically carried 500 rounds for the nose gun. For merchant ship defense, Crawford proposed 1,000 rounds stored in ammunition boxes secured within the nose section. This ammunition would need to be resupplied by carrying boxes up the ladder, time-consuming but acceptable for a defensive weapon. Communication between the nose section and the ship's bridge required installing an electrical intercom system. The nose section crew would need to report sightings, receive instructions, and coordinate defensive actions. Crawford planned a simple two-way communication system using standard ship's telephone equipment wired to stations in both locations. Captain Garrison faced a command decision. The modification would require removing the Liberty Star from service for approximately 2 weeks. The forward deck area would be occupied by construction equipment and materials, reducing cargo capacity during the modification period. If the installation failed or proved operationally unsound, time and resources would be wasted. However, if successful, the modification could provide improved visibility and defensive capability. On March 12th at 1500 hours, Garrison authorized the modification with Navy approval. By 1700 hours, the Liberty Star was moved to a fitting-out pier. The B-17 nose section was transported from storage and positioned on the dock adjacent to the ship. Crawford's team of 12 shipyard workers and welders began fabrication of the pedestal structure. The pedestal structure fabrication took 4 days, March 13th through 16th. Crawford designed a framework consisting of 4 vertical steel pipe columns, each 6 inches in diameter and 15 feet tall. The columns were positioned in a rectangular pattern 8 feet by 10 feet, dimensioned to match the B-17 nose section's mounting footprint. Horizontal cross braces connected the columns at 5-foot intervals for rigidity. The base of the pedestal structure was welded to steel base plates measuring 2 feet by 2 feet and 1 inch thick. These plates were positioned on the Liberty Star's forward deck, directly above main transverse frame locations. The plates were welded to the deck and additionally secured with through bolts, penetrating the deck and attaching to reinforcing plates on the deck's underside. Installation of the pedestal structure occurred on March 17th. A mobile crane lifted the 850-pound framework and positioned it on the prepared mounting locations. The base plates were welded to the deck with continuous fillet welds around the entire perimeter. The welding took 10 hours, with Crawford inspecting every weld for quality and penetration. The B-17 nose section required extensive preparation before installation. The internal equipment was stripped of all flight-related systems. The Norden bomb sight was removed and returned to Army Air Force's custody. The bombardier's oxygen system was removed, flight instruments were removed, and unnecessary wiring was stripped out. The 50 caliber machine gun, its flexible mounting, and the ammunition storage remained. The plexiglass panels in the nose section required replacement. Several panels had been damaged during the crash. Replacement panels were fabricated from new plexiglass sheet, formed to match the compound curves of the original panels and installed using the original framing. The completed nose section had clear, undamaged visibility in all directions. The mounting interface between the B-17 fuselage and the pedestal structure required custom fabrication. The aircraft fuselage had a circular cross-section approximately 6 feet in diameter at the mounting point. The pedestal structure had a rectangular top measuring 8 feet by 10 feet. Crawford designed an adapter frame consisting of steel channels forming a rectangular perimeter that matched the pedestal top with internal supports extending inward to contact the circular fuselage at multiple points. Installation of the B-17 nose section occurred on March 20th at 0900 hours. The crane lifted the 850-pound section and positioned it over the pedestal structure. Alignment was critical. The nose needed to point straight forward along the ship's center line, and the structure needed to be level when the ship was floating normally. The alignment process took 4 hours of incremental adjustments. The nose section was secured to the adapter frame using 48 high-strength bolts through the original aircraft mounting points and newly drilled attachment locations. The bolted connection allowed the nose section to be removed if necessary, though no practical scenario for removal was anticipated during the ship's operational life. The access ladder installation began on March 21st. Crawford fabricated the ladder from steel pipe with welded rungs spaced at 12-inch intervals. The ladder was positioned at the aft end of the B-17 nose section, where an access hatch had been cut through the aluminum fuselage skin. The ladder incorporated 2 intermediate platforms with safety railings to prevent falls during rough weather.
The ammunition storage installation followed. 4 steel ammunition boxes, each holding 250 rounds of .50 caliber ammunition in belt link configuration, were secured to the deck inside the nose section. The boxes were positioned within reach of the gun position. Additional ammunition could be stored in the ship's magazine and carried up as needed. The intercom system installation occurred on March 22nd. Electricians ran shielded cable from the ship's bridge to the nose section, routing the cable through the hollow columns of the pedestal structure. A handset was installed at the bombardier's position and another at the navigator's position. The system was tested and verified operational. The completed installation was extraordinary in appearance. The Liberty Star now featured a gleaming aircraft nose section perched 15 feet above the forward deck, its distinctive plexiglass nose cone and aluminum skin contrasting sharply with the ship's drab gray paint. The B-17 nose pointed forward like a figurehead on ancient sailing vessels, giving the merchant ship an aggressive, purposeful appearance unlike any other vessel in the fleet. Sea trials began on March 24th. The Liberty Star departed Brooklyn and conducted handling tests in the harbor and nearby coastal waters. The vessel's handling characteristics were essentially unchanged. The added weight and windage were negligible relative to the ship's 14,500-ton displacement. Stability tests revealed no concerns. The ship remained stable in moderate seas with the elevated nose section. Visibility tests from the nose section revealed extraordinary results. Chief Mate Edward Thompson positioned himself in the bombardier's station and evaluated sightlines during various maneuvers. The visibility was phenomenal, far superior to the ship's bridge. Thompson could see the water surface immediately ahead of the ship, could scan the horizon in a 180-degree arc, and could observe the foredeck and cargo handling equipment clearly. The elevated position provided an unobstructed view that no bridge-mounted position could match. The gun system testing occurred on March 26th at a designated weapons range off Long Island. Towed target rafts were positioned at 500, 800, and 1,000 yards. Gunner's Mate Second Class Robert Martinez manned the .50 gun and conducted firing tests at all three ranges. The weapon performed excellently. Accuracy was good at all ranges. The flexible mounting allowed the gun to engage targets across a wide arc forward of the ship. However, the firing revealed a significant limitation. The gun's position in the extreme nose meant that firing at targets to the sides required aiming the gun at extreme angles. The effective arc of fire was approximately 90 degrees, 45 degrees to either side of dead ahead. Targets on the beam or aft were beyond the gun's traverse limits. The installation was purely a forward defense weapon. The Liberty Star was certified operationally ready on March 28, 1943. The ship was assigned to Convoy HX-231, scheduled to depart New York on April 2nd, bound for Liverpool with a cargo of ammunition, vehicles, and aircraft components. The convoy consisted of 42 merchant vessels escorted by destroyers and corvettes. HX-231 departed New York on schedule. The crossing proceeded uneventfully for the first week. On April 9th, approximately 600 miles west of Ireland, the convoy came under U-boat attack. German submarine U-306 penetrated the escort screen and torpedoed a freighter on the convoy's port flank. The merchant vessel sank within minutes. The convoy executed emergency maneuvers, and escorts began depth charge attacks. On April 10th at 2:30 hours, lookouts in the Liberty Star's B-17 nose section detected a surfaced U-boat approaching from dead ahead at approximately 2,000 yards. Chief Mate Thompson, on duty in the nose section, immediately reported the sighting to the bridge via intercom. The submarine was running on the surface at high speed, apparently attempting to penetrate between merchant vessels to reach a favorable attack position.
Captain Garrison ordered hard left rudder to point the Liberty Star's bow directly at the submarine, keeping the target within the .50 caliber gun's arc of fire. Gunner's Mate Martinez opened fire at 1,200 yards range. The tracers arced toward the U-boat, splashing in the water nearby. Martinez adjusted fire, walking the tracers onto the target. At approximately 1,000 yards range, multiple .50 caliber rounds struck the U-boat's conning tower. The submarine immediately crash-dived to escape. Whether the damage was significant or merely prompted an emergency dive could not be determined. However, the U-boat did not surface again to press its attack. The Liberty Star's defensive fire, combined with the aggressive maneuver toward the attacker, had disrupted the submarine's attack run. The convoy reached Liverpool on April 15th without further incident.
Captain Garrison's after-action report documented the engagement, noting that the elevated observation position in the B-17 nose had detected the surfaced submarine earlier than conventional bridge lookouts could have, providing critical extra seconds for defensive response. The report also noted the limitations. The .50 caliber gun, while effective at causing a submarine to submerge, lacked the hitting power to inflict serious damage. The narrow arc of fire meant the gun was useless against submarines attacking from the beam or stern quarters. The elevated position, while providing excellent visibility, created structural concerns during heavy weather. The nose section experienced substantial movement during storms, and crew members reported discomfort from the motion. The British Admiralty reviewed Garrison's report with interest. Several Royal Navy officers inspected the Liberty Star's modification while the ship was in Liverpool. The consensus was that the visibility advantage was genuine and valuable, but the defensive armament needed augmentation. The British proposed installing additional weapons in the nose section to increase effectiveness. On the return voyage to New York in early May 1943, the Liberty Star encountered severe weather in the North Atlantic. Waves reached 30 feet and winds exceeded 50 knots. The B-17 nose section, positioned 15 feet above the deck and extending forward, experienced violent motion. The structure flexed noticeably during wave impacts. Several bolts in the mounting system loosened from vibration. The plexiglass panels, subjected to wind pressure and salt spray, showed stress crazing. Upon arrival in New York on May 18, 1943, the Liberty Star underwent inspection. Naval architects examined the pedestal structure and nose section mounting. Their assessment concluded that while the structure had survived the storm without failure, the design was marginal for sustained North Atlantic service. The repeated flexing was causing fatigue in the aluminum airframe structure. The mounting bolts required re-torquing after every voyage. The plexiglass panels would need replacement every 3 to 4 voyages. More significantly, the strategic situation had evolved. By mid-1943, Allied anti-submarine capabilities had improved dramatically. Increased escort numbers, improved radar, longer-range patrol aircraft, and breaking of German naval codes had turned the tide in the Battle of the Atlantic. U-boat losses were increasing, while merchant ship sinkings were decreasing. The desperate situation that motivated experimental modifications in early 1943 was improving. On June 8, 1943, the Navy issued an assessment of the B-17 nose installation on the Liberty Star. The assessment acknowledged the visibility advantages and the successful engagement of April 10th. However, the structural concerns, maintenance requirements, and limited defensive capability led to a recommendation against widespread adoption. The installation would remain on the Liberty Star as an experimental system, but would not be replicated on other vessels.